You've seen them, right? Those massive, graceful giants spinning on a hillside or out on the water. But have you ever really stopped and wondered how they work? How does a simple breeze get turned into the electricity that powers your life? Well, today we're going to break it all down: the science, the tech, and the incredible story of wind energy. So, first things first, before we can even talk about the turbine, we have to talk about its fuel source, the wind itself. It seems like such a basic question, but the answer is actually pretty amazing. So, where does the power in the wind really come from? Believe it or not, wind energy is actually a form of solar energy. Yeah, really. It all begins with the sun. The sun heats our planet unevenly. Some spots get hot, others stay cool. That hot air rises, creating a low-pressure zone, and cooler, heavier air rushes in to take its place. That giant planetary movement of air, that's what we call wind. Okay, so we have air moving all over the globe. But how much energy can we actually get from it? To figure that out, we have to pop the hood and look at the physics that makes it all possible. At its very core, wind energy is what scientists call kinetic energy. It's just the energy of motion. The logic is pretty simple, really. The more air that's moving and the faster it's moving, the more energy is there for the taking. It all comes down to the mass of the air and its speed. So, when you break it down, there are three key things that determine just how much power is available. First, there's the density of the air. Then, there's the area swept by the turbine's blades, which, by the way, is why these things are getting absolutely enormous. But the third factor, that's the real game changer. It's the wind's velocity cubed. Let's just pause on that for a second. Cubed. This isn't a simple one-to-one relationship. We're talking about an exponential jump. It means a small increase in wind speed doesn't just give you a little more power, it gives you a lot more power. So, what does cubed look like in the real world? Check this out. If the wind speed doubles, the available power doesn't just double or even quadruple, it goes up by a factor of 8. This right here is the reason why finding the perfect location, even one with just a slightly higher average wind speed, is the holy grail for wind farm developers. All right, now that we understand the fuel, let's build the machine. We're going to put together a modern wind turbine, piece by piece, so you can see exactly how this incredible technology works. First up, we need the tower. Its whole job is simple but crucial. Get the blades as high as possible. Why? Because the higher you go, the stronger and smoother the wind is. As you can see, they come in a few different styles, but they're all about reaching for that better, more powerful wind. Perched right on top of that tower is this box, called the nacelle. You can think of it as the brains and the muscle of the whole operation. It's packed with all the good stuff: a gearbox, a generator, and all the computerized controls. This is where the physical rotation of the blades gets converted into clean electricity. Now, a modern turbine isn't just a static windmill. It's a smart, dynamic machine. It has what's called a yaw system to turn the whole head so it's always facing directly into the wind. And even cooler, it has pitch controls that constantly adjust the angle of the blades themselves to catch the perfect amount of wind and to protect the turbine when the wind gets too crazy. And there it is. You put all those parts together: the solid foundation, the tall tower, the smart nacelle, and those huge rotor blades, and you get this elegant, sophisticated machine. Every single part working in harmony, with one goal: to turn the invisible power of the wind into usable electricity for all of us. But a single turbine, as impressive as it is just one instrument. To really make a difference, you need an entire orchestra playing in tune. So let's zoom out and see how these individual machines work together as a full-blown power plant. So, a whole group of turbines is called a wind farm. And they don't just operate on their own. They're all wired together into a central control system, a kind of digital nervous system called SCADA. It lets a handful of operators monitor every single turbine, tweak performance, and smoothly feed all that power into the electrical grid. Of course, no form of energy is perfect, and there are always trade-offs. People have some really valid questions about wind power, so let's take an honest look at a couple of the biggest concerns and see what the data has to say. Okay, first up, noise. You see those enormous blades slicing through the air, and it's a fair question to ask, hey, how loud are those things, really? Well, this is where context is super important. This chart shows that from about 300 meters away, a pretty standard setback distance, the sound from a wind turbine is actually quieter than the hum of your refrigerator or your window AC unit. All right, another really significant concern, and one that gets a lot of attention, is the impact on wildlife, specifically on birds. It's a serious issue that the industry and conservation groups have put a lot of work into understanding and mitigating. So again, let's put this into context with the data. Now, this chart breaks down the estimated causes of bird deaths. And while wind turbines are on the list, the numbers are dwarfed by other man-made sources. Buildings and windows are a vastly bigger problem, followed by things like cats and power lines. It doesn't mean the risk is zero, but it does help us understand the scale of the issue. So we understand the tech, we've looked at the impacts. So where does wind power stand today on the world stage? The answer, in one word, is booming. Just to give you a snapshot, let's look at this data from a few years back, in 2016. Even then, you can see the major players. China was already leading the pack with a huge share, followed by the US, Germany, India, and Spain. This was already a truly global industry. And what's truly mind-blowing is the speed of this change. This graph here says it all. You can see the exact moment it just took off. That's not a line, it's a rocket launch. In just a couple of decades, wind went from being a niche idea to a massive global force in electricity. And that curve has only gotten steeper since. And that brings us to the big takeaway. The growth of wind power is undeniable. It's exponential. So the conversation really isn't about if wind energy will be a huge part of our future anymore. The real question we have to ask ourselves now is, how do we best manage its incredible rise?